combinations story refreshed a little bit, because our goal is to look at the last section of chapter 12, 12.5. So we were dealing with that section 2 of chapter 13 to get some help. We noticed that there is a special formula for so-called combinations. So from total n to select R objects without caring about the order in which we select it. In other words, do not permute, not have any permutations, in other words. So formula for permutations look like n over n minus r factorial. We preferably used calculator for that. But then when killing all the possible permutations comes into play, we use this extra r factorial in its denominator. So that's how the so-called combinations produced. And the key idea, we didn't care about the order of elements that we select. And of course, this is a formula that gives us the shortcut to write this algebraically, because it's not really coming like that intuitively. Intuitive way is definitely not the same. And the key idea in using this formula was to check and see whether we care about order or not. Let me do an exercise. They usually examples related to the lottery games or things like that. And let me try to refresh, do one problem, and then we'll go to our last section and try to find one here. So whenever, like in 57, they say, how many orders? Well, it means order is important, but that's not combination. So that will be permutation. So I'm trying to find the exercise that could be relevant here. And whenever they say order and they clearly spell out that, but for example, '59 looks like here they don't really give you any information about the ordering, so why don't I try that one? Maybe a little bit more on the challenging side, but we can try it just to see that combination story is utilized. So they say 15 members, 4 of the players are pitchers, and remember, and the remaining 11 play at any position. So there are 4 pitchers and 11 that can play at any position. So that's how they give us total of 15 players. Okay. So what they want is to produce 9 players team that don't have any order in informations. And the question might be, do we have to really utilize this information or not? In other words, if you're out of 15 players, you want to choose 9, right, for your team. would you really have to have some particular number of these pitchers or any position players that actually include pitchers, right? So looks like since there is no information, then I don't think we really care whether we select a pitcher or player for any position. So they say how many different teams are possible. Well, we have a combination because we don't order players in a team. And don't say you're the first player, you're the second. It doesn't matter which order looks like. So out of total 15, right? We're trying to choose 9, and that's number of teams possible without any order at all. And I'm not gonna care for using the formula. What I'll do is I just put numbers in my calculator. So what we need is to go for scientific calculate, right? And we'll go to combinations where functions are, right? Functions, and here's number of combinations. And then go back to main and put numbers in 15, comma 9. So straightforward calculation, and we get whatever answer which we are here. So the point of story is we, out of 15 total players, decide to select 9, right, to get a team. So we can choose first 9 of them, or we can choose last 9, or we can choose first player and then last 8. So there are all kinds of combinations possible. So keeping this in mind, I'm returning back to chapter 12. So we're going to look at the last section we need for this class. We're going to start 12.5 today. And I would say there is not much in this section, even though the problems may seem to be a little bit unpleasant, but they're not hard, and they're all explained here what we're trying to do. So if you're taking the sum and raise it to the power of 1, or if you're raising it to the power of 2, then you simply going to multiply this x plus a with itself, right? Because square means multiply it twice. And of course, the previous product, power of 1, means just not multiply, just take it the way it is, right? Power of 1 means don't do anything, so just x plus a. So now how do you produce these terms? When it's Alex say FOIL this. Yes, so the idea is that you have power of x, the largest will be squared. Then the smaller power of x will be 1 less, first power. And finally, there'll be 1 less, which is a 0 power of x, which means no x here, right? X to the power of 0 is 1. So that's the first number. Second number is a. So the powers of a will be analogous, but going in the opposite direction. What does that mean? Well, a will be raised to the power of 0. Notice that the 2 and 0 will be 2. A will be raised to the power of 1. So that's a term. That's the middle one here. So 1 and 1 is also 2. And for the last one is going to be a squared. So we have 0 plus 2 is also 2. And we need to know coefficients. That's the key idea. So we are going to look at the no coefficient, which means 1 here. The last is also 1. and the second term will have a coefficient of 2. And turns out they coming out as combinations, because when you multiply x with x, you get x squared, right? So the only term with x squared is choosing x in the first parentheses and x in the second parentheses. So out of 2 possibilities, you take both of them. Out of 2, you take 2. Out of 2 what? Well, 2 x's, right? In the parentheses. You have to take n1 here, n1 here. So when you multiply x by x, that's how you produce that x squared term. So how many possibilities will be from 2? Choose both. And with the last term, with a 0 power of x, out of the same 2 possibilities that I could possibly choose, I have none of them selected. Because notice that there are 2 parentheses, both have x, but to produce x to the power 0, it take term with no x, as well as the other term with no x. That should be plus here. So x plus a times x plus a. So I take a from the first and a from the second parentheses. So I don't take x here. So I take 0 x's from here and 0 x's from here. So out of 2 possible selections with x terms, I take 0. And that's how I get my last term. So out of 2, I get 0. And of course, you can check this with a calculator. Calculate combinations 2 choose 2 and 2 choose 0, and they both will be 1. In fact, why don't I do this? So get combinations from 2 to use 2. That's the first one. And for the second one, I use 0, right? So 0 here. And both of them are equal to 1. So it's not surprising. And analogously, I'm going to deal with a middle term. For the middle term, I need to have only first power of x. In other words, from parentheses, I have to select one x and the other not x. And the way to do this will be, again, combinations, because I don't care in which order I do these selections. From first parentheses or from second parentheses, I have to choose only one x. So out of 2 possibilities, I take only one x, and the other I don't take. So I can take x from this parentheses, or I can take x from this parentheses. If I take x from first parentheses, the other is no x, and same for the other one. If I take x in the other parentheses, the first is no x. So out of 2 choices, I have to choose only one, and it's going to be number 2, as we can see here. And you can see that if I put 2 comma 2, it is indeed 2 comma 1, sorry. It's going to be 2 choices, and that's the coefficient exactly with my middle term. And of course, we'll put plus signs everywhere. So this is going to be our trinomial. And the reason I do this is because I want to produce the formula. So analogously, I will produce the formula for the last one. You can try with the first one. So it'll be x plus a multiplied with itself 4 times, right? So I will use the same exact pattern, and I'm gonna see what powers of x are possible, and then I'm gonna produce coefficients with these powers of x. So I'll just write this a little bit slower, so I'm trying practicing with this new computer. So I hope I'm getting a little bit better at that. That still takes time. So anyways, we have 4 parentheses. So the largest power will be if I select x from my first parentheses and x from second and from third and from the fourth will be x to the power of 4. That's the largest power of x I can possibly get, right? Then what about its friend A? Well, the power is 4. So the sum of powers must be 4. So 0 with 4 gives me 4. So that's my first term. Next will be x cubed, right? Because now we have power of 1 less. So it's either take this first 3 x's or first and last 2 and so forth. So power of a then will be 1. Again, powers 3 and 1 will give us 4. Next term is x squared, and power of a is 2. So notice that powers of x start at the largest and keep going down, and power of a start at the lowest, which is 0, and keep going up. So that's standard procedure in so-called, so down, it means it's power of 1, right? So just x. And then the last, so this will be 3, because the power here is 1. And the last one will be x power of 0, so no x in other words, but a will be raised to the power of 4. So these are the terms. So what about coefficients with these terms? I say, Alex, I can see what coefficients there are. And here they are, 4, 6. How do they produce them? Well, they take combinations. That's the idea. So for the first one, I take combinations out of 4 possibilities to choose 0. In other words, I have to take all 4 x's for my x to the 4th. So I have to take this x, multiply it with that x, with that x, and with that x, and that's how I produce 4th power of x. And 0 power of a, because I don't use any a's, 0 a's. So combinations 4 choose 0, that happens to be 1. So whenever you choose 0, you don't choose anything, you just turn around and leave. So only one way to do that. For the next one, I'm going with choosing 3 out of 4. So that'd be combinations for selecting from 4 possibilities 3. And this ends up being number 4. How come is that? Well, I can choose first 3, so I leave out the last one, or I can leave out one before last, or second, or first. There are 4 ways I can leave out or disregard one of these 4 parentheses. So it is intuitive, but of course you could put this in a calculator as well. So from 4, choose 3, and that will be, of course, 4. So power of 3 for our letter x. So for the next one, I'm going to take out of 4 possibilities 2, because I need to get squared. Yes, Alex, what is that you write? It's hard to understand. So more careful. So try to put 4. So this parentheses, and then it's 4, comma 2. So once you understand this, that's it. You got the idea of this whole section. So 4 parentheses, I have to choose 2 x's from them. So I can choose first 2 or last 2 or various combinations of them. So what's combinations of 4 choose 2? They say here 6. So it has to be 6. Let us check this out. How many ways we can choose out of 4, 2? Definitely, it's not that obvious. And that's why I recommend you to use a calculator. So from 4, not from 6. From 4, I choose 2, and it's 6. So you can see that indeed this all works. And then finally, we're gonna move to the selecting 1, right? So combinations from 4, choose only 1. So you can choose either first or second or third or fourth. So there are 4 ways to do this. 4. And this is gonna be 0. So no choosing any x's. So I just get one way not to choose. So it looks like we got the idea of this decompositions, and we got the idea of the formula. That's the key point. And these coefficients, they decided in this section, instead of writing the number of combinations, they put this bar in the parentheses. But look at the formula.
La
It's
sacar a la cara.
So it is the same thing. So it looks like we have n factorial on the top, difference n and r factorial. Here we have j instead of r. Okay, difference n and j factorial. So it is identical thing. And this is all the section talks about. So now they can get variety of examples in here. Notice that general formula for power of n is as following. From n you choose 0, then from n you choose 1, and so forth. You keep getting larger and larger up to choosing from n with a power of n. And here's power of a is, there's no a means it's 0. So you get x to the power of n, a0, n minus 1, a1, n minus 2, a squared is missing, and so forth. So I will not bother to write this down. I will just go and do an exercise. And then I'll say a couple of words about final exam that is coming next Monday. We'll have extensive practice for that, of course. So we already noticed that these first group of exercises referring to skill building has to do with combinations. It's just different way to write down the combinations. For some reason, without a C, they put the parentheses. I think it's good though that you see it, because in some books they like to write it like that, combinations. So let's say if you do exercise 6, I would follow the strategy of the previous section that we saw. Use a combinations out of 7, choose 3. And I would definitely put this in a calculator rather than using that annoying little formula. Nowadays in calculator, I can just add it. I put 7 on the first position, so I don't have to re-enter combinations, and then 3 on the second position and get the answer right away, 35. Of course, you can use the formula if you like to do that, but I would say you don't want to make a mistake in your arithmetic. That's why I would recommend you to not use formula. Just put it in the calculator. So how about if we take, let's say, power of 6. Let's take something, I don't want to use the word nasty, but something longer than previous. And for that, I'm going to need to use a little bit of room. So I'm going to use a new page here, exercise number 6. So if you can do one problem here, then you can do all of them. Oh, 25. That wasn't 6, it was 25. I wanted to take power of 6, because we just looked at power of 4, right? And power of 2. So why don't I look at power of 6? So expand this square root x plus square root 2, which is raised to the power of 6. So roughly speaking, I need to think about taking the square root of x and square root of 2 and multiply it with itself, and again and again and again 6 times. That's what power of 6 means, right? So you have to times the same thing with itself, times again. So I say dot, dot, dot. And again, root of x plus root of 2, 6 times. So that's going to take you a while if you do this by hand. So the recommendation is use the formula. So what the formula says? Well, square root of x will be raised to the power of largest possible, which is 6. And then square root of 5 will, square root of 2 will be raised to the smallest possible, which is 0. Notice the powers added always need to give you 6. There'll be some coefficient, we call it as a combinations from 6 to 0. So I just care about powers. That's my first term. Next term. Now power of largest gets smaller, so square root of x will be now raised to the power of 5. Let's see, one step smaller, but square root of 2 will be raised to the power of 1. Let's see, Alex, square root of 6, square root of x to the 6 is like x cubed. Yeah, I'll do this on the next step, of course. I'll simplify it. I just want to write out these terms. So from, what do I do now? 6. Notice we're always going to choose 6. I take 5 square roots of x to produce that thing. When I say, what about 1? Well, 1 is not participating. So 6, 0, 6, 5. Next term will have coefficient 6, choose 4. You see the pattern? The next term will go down 6, choose, to still practice. 6, choose 1 less, 3. Then we'll go 6, choose 2. See, that's a lot to write, but that's a pretty nasty polynomial. I don't think you were ever asked to do anything like that before, to multiply 6 parentheses with each other. We never went farther than power of 3, I believe, in algebra classes. But now you can deal with just about any power, and that's the idea. You can use with power of million. I say, so I have to write out million terms, Alex. Well, you can deal with it if you really have to, but I hope you're not going to have to. And the last term will be out of 6 to choose 0. So that's coefficients. And what the powers are? Well, the powers are just keep changing in the same pattern. So square root x will be now, instead of power of 5, we'll go down to 4. And the friend of square root of x, which is radical 2 here, will be raised to the power instead of 1, increased by 1 is going to be 2. Please notice the sum is always going to be 6, sum of the powers. So root of x is now raised to the power of 3, and root of 2 is now raised to the power of, well, also 3. So we're like halfway. So next will be root of x squared. So keep getting smaller, and the other factor has powers that keep getting larger. So that's 4. Now here's root of x power of 1. I can put it for just in case, it doesn't matter. And root of 2 will be raised to the power of 5. Okay. So the last piece is a square root of x power of 0. And the square root of 2 power of 6. Again, sum of powers is always 6, because that's a 6-powered polynomial we expand. So now we can calculate what these combinations are. So 6 choose 0 is always 6. X to the power of 6 square root of x. You multiply square root of x, square root of x is just x, and you do it 3 times, so that'd be x cubed. And square root of 2 to the power of 0, 0 power of anything is 1, so we don't write it. And we'll move to the next, and the next, oh, from 6 to choose 0 is 1. Sorry, I wasn't careful. Only one way to choose 0 is not to choose anything. So here will be 6, right? And then what be with x? How can I write it? Well, some people can say x squared times root of x if you want like that, and root of x times root of 2 will be a root of 2x, because we have root of 2 and x to the 5th. We can think of it as a separating 1 power of square root, and the other piece will be square root x to the fourth, and square root x to the fourth is just x squared, right? Because square root is power of 1/2 times 4 is just 2. And so, you sure? Well, let us put this in the calculator. Don't have to think too hard. So you go combinations, 6, choose 0. You see, it is just tedious. Once you wrote it out, you could just, I guess, put numbers in little by little. So you get first coefficient 1, second coefficient, you choose 1. Will be 6, just as I wrote. Now, if you choose 2, that would be 15. You see, now it starts to be a little bit less pleasant, because when you choose from 6, choose 0. Oh, I should have put 6, choose 1. Well, actually, 6, choose 5 is same as 6, choose 1. You will see that. So 6, choose 4 is the same as, I think it's good I made this misprint, so you could visualize that these coefficients are actually always going to be the same. And then finally, 6, choose 0, and I should have put 6, choose 6. See, you didn't notice this misprint. So I have to go 6, choose 0, then 6, choose 1, 6, choose, but actually I had to put 6, choose 6 here to be correct, because I wasn't careful. Why? Because square root x appears 6 times. So in first parentheses, I have to take square root x, and in the second, and in the third, and in the fourth, and so forth. So I choose all 6 of them. So from 6, I choose 6. From next, I go 6, choose 5. Next, 6, choose 4, because I need fourth power. So it has to be the same power here and here. But whether I choose 6 or whether I choose 0 of them, that was written correctly, actually, the results are the same. 6, so choose 6, 6, choose 0 will give us the same values. I think it's good to double check. You should, do you see the calculator? Let me share this screen, because I'm not sure if it's sharing. So from 6, choose 0. Let me write these again so you can better see it. So I'm going to re-enter all of them. So functions, combinations. I think that's an interesting thing to observe. So choose from 6, comma 1. I'm gonna do this 6 times. 6, comma, again, combinations. From 6, I choose 2. Just to show you they are the same in pairs. I think that'd be good observation for the future, if you ever, of course, need it in the future. So go back and get another combinations. 6, choose 3. So now they're gonna start to repeat, because we went like halfway. So 6, choose 4 has to be 15, just like that. So let's see that. Combinations out of 6, choose 4. You can see it's 15. Next will be 6, and the last will be 1. Interesting, right? I'll show you this, and it's very intuitive as well. And that's why we actually went over combinations. So one, I hope, starts to feel a little bit better towards it. To say, oh yeah, it is seem to be indeed intuitive. So 6, choose 2, right? Parentheses. So that's 2 was already, so now it's 5. So it's, you have to be careful, keep track of what's going on. So notice that we go 20, that's like a middle term, 15, 15, 6, 6, and the last will be 6, choose 6. I can put it here. 6, choose 6. And that's indeed 1, right? So 6, 15, 20, and then starts to go down and repeat. So let me go back to this, share. Board. So here we have it. 6, choose 4. It's gonna be 15, right? And now what's with the powers? So it looks like x will be just squared because this is my square root that disappears. And that guy will give me 2 because square root 2 squared is 2. So it'll be just x to the second times 2. Or one can say it's 30. So you could actually write this as a 30x squared, but that will be, I guess, pretty confusing because one will say, how come it's 30? Because we no longer have the combinations. Well, because the 2 came out, that's why. So let me write this x squared. So anyways, I just here to give you an idea. So next was 6, 15, that was 20, right? Combinations for this was 20. And now x will be outside because we actually deal here with a square root of x squared because power is 3. So I have a square and I have another square root of x because it's cube. So I have 3 factors of square root of x. And with root of 2, I have a square and another square root of 2. So we have a x with this and a 2. And then also we have a square root from 2x. And this is great. And we have another piece coming. So where should I write it? Maybe a little bit lower to finish with this. It's a tedious exercise. So I would say if you can do this once, then you don't have to worry about doing it again because you're going to just repeat the same thing. So different numbers, of course. So we have 6, 3. So now we have to go 6, choose 2. So 6, choose 2 is the same. We know this as a 6, choose 4 was 15. So next term will be 1, 5, right? So what's with power of x? Well, the square root of x squared is just x. And the square root 2 to the power of 4 will be 2 times 2, which is 4. So I'm not going to write 60, but we just do this if you want to. Finally, we get to the end. It's 6, choose 1, which is just a 6. And the radical x stays, and there's a square root 2 that I could think of, square root 2 to the 4th, right? Times another square root 2. That's how I split 5th power, because I need the even power, so I kill the square root, so it'll be just a number 4 in here, 2 times 2. So it's 4 square roots 2. And then I have also square root of x. I put 4 and keep 2 and x inside the square root. It looks a little bit more compact. And the last term will be just 1 for this coefficient, so I don't have to write it. And that will be 1 for that coefficient, so I don't have to write any square roots. And what's square root to the power of 6? Would that be 8? Right, because that's square root of 2 multiplied with square root of 2, which is just a 2. But then we have power of 6. So we repeat it again, and we repeat it again, so that'll be product of 3 factors of 2, which is 8. So this lengthy, nasty thing is produced, and it's actually being produced by multiplying 6 parentheses, like we started with. That's how the old way would go, and it'd be a huge mess. You would probably need a few pages of paper and could mix up when you collect like terms, and eventually you should get this result. And of course, using a formula is always helpful thing to go with. So I guess I'll let you try to not go through the whole thing, but maybe just see a few coefficients would be a very good idea to just start make sense out of it. So next time I will do another exercise and we'll start to discuss the final exam, because final will be a week from today on Monday. So next week is the last week of class. Semester ends, it's going to be week 12, so it's week of finals. So I'll give it to you on Monday. I'll email it to you probably earlier than Monday. So that way you will have plenty of time to do the final. If some people do it wrong, I'll give you another attempt. Don't worry, but you should be on time. The key idea is I must return in the grades on Thursday next week late at night. So prior to that time, I have to have all of your work. All of work, because if I get something later, I can't really put it as a part of your grade. So keep that in mind, and this week we will take it seriously, preparing for the final, just like we did with the midterm. I'll give you a clear idea what will be on the exam, so you will know, and it'd be analogous couple of exercises. Couple means 2 exercises exams, so I'm sure you're gonna make it. And please do the homework. So the last section will be 12.5. We went through chapter 12. I'm pretty happy. That's our goal. Finish chapter 12 for this class, and that's what we did. And I also had a chance to describe a little bit what these combinations are all about. So these things, like we did 6, and we'll do another one next time. So I guess it's time to end it for today, and I'm not going to give you any more quizzes because we're done with material, so we'll just keep on practicing for a final exam on Wednesday and then also on Friday. So next Monday you will be, I'm sure you will be ready. And if not, well, you'll have another few days to get ready, and that will be, of course, on Zoom next week as well, and on Monday and on Wednesday and on Friday, of course, because semester extends into next week, just to clarify things and to help you if something is unclear. And of course, I will accept work if it's late, but do it. If you just keep on postponing it, the material gets overwhelming. It just piles up and you might not be able to take it. So do it this week, okay? And send me your homework. Chapter 12 is homework. I say, should I do combinations, permutations? Yeah, you can do it also. Why not? It will make me very happy because we do combinations here in this section anyways. Okay. So I'm gonna stop to record. No quiz. I'll let you go. Enjoy this nice rainy day. So, any questions?